In this video, I'll be doing a detailed solution to the question you see on the screen here from the 2024 Cambridge A-Level Maths Exams Paper 2-1. If you're looking for a different question from this paper, have a look in the playlist in the description below. Or if you're looking for a different paper entirely, search around on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we're not in a classroom, we're on YouTube, so take advantage of that, use the pause button, even change the speed at which you view it. If you do find this video useful or any of the videos on my channel, I do greatly appreciate a like, a subscribe, a share, or even a super thanks. In question 4, we're given this trigonometric identity and we're asked to show that one side equals the other basically. What I often say is take the more complicated side and make it look like the other side. Now, a lot of students, I think, a lot of people would agree, this is the more complicated looking side. It's not in this case. And I would argue it's not because they all have just tan of theta. Tan of theta squared, sure, but tan of theta, tan of theta. This side has tan of 2 theta and tan of theta plus 45. Much more complex looking. So it's this side I'm going to rip apart, put together different ways and hope this starts appearing. And there's some obvious candidates to that. Tan of 2 times an angle. We have a formula for that. So that'll be 3 times. Let me look up my notes here. Tan of 2 times an angle is 2 times tan of the original angle. So let's put a bracket around. Whoa. So I'm replacing this with what's in this bracket. This is all in your formulas. 1 minus tan squared theta. Another great thing is this bottom row is what we're looking for. So it's a nice clue that we might be on the right track there. And then the next one would be tangent of an angle plus an angle. I won't write out the formula, but it's let me read it out to you. It's tan of the first angle plus tan of the second angle divided by 1 minus tan of the first multiplied by tan of the second. So I'm going to apply that here. Let me take that again. So tan of the first is tan of this theta plus tan of 45. Tan of 45 is 1, so that's going to disappear quite nicely for us. Divided by 1 minus tan of theta multiplied by tan of 45, which, like I said, we'll see is 1 now in a moment. Okay, let's play around with that and hope it looks like the right side. Hopefully we can see some of it already. Actually, you know what? Save me writing a lot of this again. That's just 1, disappears, and that turns into a 1. Okay, so what do we need to do to make this look like this? I'd like to add them together. But they have different bottom rows. But the bottom rows do look similar. A lot of students get stuck here. They're tempted to start multiplying this by tan maybe everywhere. But no, that destroys the 1. The secret is to notice what this is. This is a difference of squares. I'm going to write this side again here. 6, 3 times 2 is 6, tan theta. The bottom row is 1 minus tan theta multiplied by 1 plus tan theta. You don't have to do this if you see how to move this into that already. There's a difference of squares there. If you multiply this back, 1 times 1, it's 1. Tan by tan and a minus tan squared. And then minus tan times 1, tan times 1. They cancel. So you're left with that. This bottom row is tantalizingly close. Tan theta plus 1 on top. Or maybe we should write 1 here so it's not as confusing. That's on top. 1 minus tan theta is on the bottom. And if only there was another 1 plus tan theta on the bottom. And the secret is just put it there. Just cheat and put what you want there. That would be very nice, wouldn't it? And you can fix your cheat by putting another one up here. 1 plus tan theta. Obviously these are the same, so you could just write squared either. This bottom row and this bottom row, they're the same. Let's add it all together. Let's multiply it out and add it all together. We'll get tan squares on top. Tan by tan, we'll get on the top, we'll get tan squared. We're going to get this appearing. We'll also get 6 tans plus another one plus another one. We'll get 8 tan thetas, and numbers 1 by 1. We'll just get the 1 by 1. Same as here. On the bottom row, let's put them back together. Back into this. In the bottom row, we'll get 1 minus tan squared theta. You didn't have to separate this out. If you recognize that this was a difference of squares, you could have just multiplied this one here. Up here either if you wanted. You didn't have to show them that this comes apart just to put back together. I was just showing you guys. Okay, that's it. That's the answer to part A. In part A, we proved that this equals this. In part B, they've given us this first equation and told us it equals 4, and to solve that. Now, what I hope you take the leap is, we don't want to solve this equation. Let's just put this equals to 4 as well, and we solve this equation here. We do that by just start moving things around. For example, this bottom row can just multiply by the 4, and we get tan squared plus 8 tan plus 1 is equal 4 times 1 is 4. 4 times this minus 4 tan squared. What we have here is a quadratic. Something squared, something, and no somethings. Let's just rearrange it all so it equals 0. Move this over, sorry, it should be 4 of these here. 4 tan squares. Move this all over on the left. We'll get 5 tan squares. We'll get 8 tan. And number wise we'll get minus 3, and this will all equal 0. So this is just a quadratic, something squared, something, and no somethings. It looks like we should be able to factorize this. We can't, but it looks like we should, like 5 and 1 for this guy, a 3 and 1 here. So let's see, 3 here and a 1 here. It looks like 5 plus 3 can get 8. It's like we can never get the plus to work out because we need a minus. This guy needs to be a minus, and this guy needs to be a plus. So unfortunately, can't get to the 8. So it's tantalizingly close, but we can't do it. So instead, we just go ahead and use the minus b formula. Remember, a is equal to 5. That's just the number in front of here. B is equal to 8. That's the number in front of the x, or in this case, the tan. And c is equal to the number left on its own there. And the formula tells us that x is equal, or in this case tan theta, is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Let's just fill that in with the numbers. We get tan theta is equal minus 8 plus or minus the square root of 64, that's 8 squared, minus 4 times 5 times minus 3, all over 10. That's tan theta is equal, we just put, well yeah, let's clean this up. We get minus 8 plus or minus, that becomes 20, or sorry, 20 times 3, that's 60, becomes 124 over 10. If we put that into a calculator, because you pretty much have to at this point, we'll find that tan theta is equal, I'm running out of marker so I'm pushing down here. You get two options. You get 0.31353, or you'll get minus 1.91355. That'll be the two answers there. But they didn't ask us for tan theta. They asked us for theta. They told us it was, it's right here, theta is going to be bigger than 0 and less than 180. So what is theta? Well, here's two options for tan theta. So we can just get theta is equal, the inverse tan of that will give you 17.4. That seems okay. And next one, it will give you, your calculator will, if you put this in, you will get minus 62.4. So many students leave this as their two answers. They walk away, they've lost the mark. Minus 62.4 is not an answer. So what is? You need to remember your calculator is stupid. So you need to remember what tangent looks like. It looks like something like this, and it stays repeating on forever. This one here, this number here, out here, your calculator is smart. It it finds that, and that's the right one we want. Remember, this is 90 degrees. This here is 180 degrees. So we want it everywhere between here and here. So the calculator got your right answer for this number. That's this one. This is right. The problem is the calculator for this one, minus 1.9, let's say down here. It went to the closest one and it found here, which is not the right. It's outside the range we want. So we need to know that the calculator, the mistake it makes, we need 180 added onto it to get this one here. So we need to add 180 onto this, which is 117.6. So just be careful, don't throw away the mark after such a long question. Be careful whenever you get your calculator to answer sine, tangent or cosine. Just double check your answer. Okay, that's it for question 4. It was a long question for me because I shaved in between it. It's been a few days in between it, in fact. I got called away in a bit of an emergency. But if I missed anything, because I did this in 2 parts, let me know. If you missed anything, if you want to clarify anything, ask me a question in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.